Assalamualaikum and greetings to all of my friends. My name is Nur Aina Natasha binti Hassan as the moderator to conduct our presentation today. Today, we are from Group 5. We'll present about our algebra project. Before we start our presentation today, I would like to state that we are doing the project according to our subject, which is algebra, and its subject code is BIC 10303 under the teachings of our lecturer, Dr. Nur Yusliza binti Abdullah. For your information too, as stated, our project's title is Algebra Real Application. Next, let me introduce the members of the Group 5. The first one is Nur Aina Natasha binti Hassan, which is me, Farisha Hajar binti Muhammad Nazari,
Hi.
Zarif Takif bin Zafrul Ibrahim,
Hi.
Nur Artasha binti Muhammad Ramli,
Yes, me.
Nur Badaria binti Syed Ali, and Nur Aisyah binti Ibrahim.
I.
According to the instruction for the project, we need to choose one trigger between all of the triggers, and we choose business. Use of algebra is essential in every profession, including business. Business owners employ algebraic procedures to determine their earnings and losses. If a piece of equipment is in stock, a business person will utilize algebra to assess whether its value would not decrease. The business owner also needs to figure out the lowest price at which a product may be sold while still making a profit. Algebraic operations must be mastered in order to effectively manage money because exchange rates and interest rates are frequently represented algebraically in the finance sector. With the research of questions that includes our chosen trigger, for the first question, we decided to choose the solve the question stated by using Cramer's rule. As we will start presenting now, I will give the authority to Badaria to present the first question and its solution.
Okay, so for question 1, we will solve this question by using Cramer's rule. The question is, a group of 3 friends decided to buy themselves 1 scoop of ice cream. There are 3 flavors of ice cream offered, which is pineapple, strawberry, and vanilla. Given that the amount of scoop of ice cream with their total price as shown in table. They only want 1 scoop of pineapple ice cream for each of them. However, the total money that they have at that moment is only 50 ringgit. Will they able to buy ice cream within that amount of money? By using the Cramer's rule, we will solve this linear equation. So firstly, we will let x, y, and z be the flavors of the ice cream, where x equal to pineapple, y equal to strawberry, and z equal to vanilla. Then we will transform that into system of linear equation, which is 2x plus 3y plus 2z equals to 37 is the first equation. Second equation is 3x plus 2y plus 2z equal to 39. And the last equation is 5x plus y plus z equal to 44. So step 1, we will state the matrix of A, B, A1, A2, and A3 as shown in this slide. Next, for the step 2, we will find A, A1, A2, and A3, which is A we will get 7, A1 we will get 49, A2 we will get 35, and A3 we will get 28. Next, for the step 3, we will find x, y, and z. So, to find x, we will divide A1 with A, and we will get x equal to 7. Y we will divide A2 with A, and we will get equal to 5. Z we will divide A3 with A, and the answer is 4. So the price of 3 scoop of pineapple ice cream is equal to 21 ringgit. For each scoop of the flavor, we will get pineapple equal to 7 ringgit per scoop, strawberry equal to 5 ringgit per scoop, and vanilla 4 ringgit per scoop. However, the friends want one scoop of pineapple ice cream for each of them. So the total amount that they need to pay is 21 ringgit. In conclusion, their money is not enough to buy all the ice cream that they want. Thank you.
Thank you, Badaria. For the second question, Atasha and I will explain the question and its solution. For the second question, Ali, Bob, and Ravi bought tickets for three separate performances. The table below shows the number of tickets bought by each of them. If the total cost for Ali was 122 ringgit, for Bob 87 ringgit, and for Ravi 146 ringgit. Find the cost per ticket for each of the performances using Gauss-Jordan elimination method. According to the schedule, Ali bought two concert tickets, one orchestra ticket, and one opera ticket. Meanwhile, Bob bought one concert ticket, one orchestra ticket, and one opera ticket. Then, Ravi bought one opera ticket. To solve it, first let X represent concert ticket, Y represent orchestra ticket, and Z represent for opera ticket. Then, according to the schedule, make the linear equation. First equation, 2x plus y plus z equal to 122. For the second equation, x plus y plus z equal to 87. And for the third equation, 2x plus 2y plus z equal to 146. Arrange the equation with the matrix form. For the first step, let row 1 change its places with row 2 and row 2 changes its places with row 1. The solution will take place at the second step. Next, let row 2 equal to row 2 minus 2 times row 1, and next, let row 3 equal to row 3 minus 2 times row 1. For the third step, let row 2 becomes negative. The solution will be at the fourth step. For the fourth step, let row 1 equal to row 1 minus row 2.
Then let row 3 becomes negative. And for the final step, let row 2 equal to row 2 minus row 3. In conclusion, the answer for the cost of one concert ticket is 35. For orchestra, 24. And lastly, for opera ticket is 28.
Thank you. Let's proceed to the next question. Hajar and Zarif will present the question and the solution.
Question 3, inverse matrices. The question is, Dina buy for 3 days in a trip to Cameroon. So Dina wants to know the price of every type of fruits because she wants to sell it back. On Monday, she sells 13 star fruit, 8 cherries, and 6 blueberries, and the total is 101 ringgit. The total that she sells on Tuesday is 78 ringgit with 9 star fruits, 7 cherries, and 4 blueberries. For the next Wednesday, the total she sells is 47 ringgit with 7 star fruits and 4 cherries. By using inverse matrix, create C programming and state the output.
Alright, without further ado, in order to solve this question, first of all, we need to assume that X is star fruit, for Y for cherry, and Z stands for blueberry. So as you can see, the equation below, the equation is formed from the question statement. You can see in the left hand side, from the this is the equation that formed from the question statement. Okay, For the second step, you can see second step in the left hand side, we need to take the equation from the system of a linear equation and write down the simultaneous equation in matrix form, which is AX equal to B, or we call it as augmented matrix form as shown below. Okay. Next, step 3. In order to find the x, we need to use the equation of x equal to inverse A times B, but to get the inverse, we need to use the elementary row operation ERO for matrix A. Okay, in the you can see in my right hand side, the 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 workway. Okay, so as you can see here, the first equation at the left hand side is matrix A, while in the right hand side is identity matrix. So the purpose to do ERO is to get identity matrix in the right hand side, in the left hand side, and the inverse A in the right hand side. Okay. So the first step is we can see here we multiply the first row with 1 over 3 to change the 13 to become 1. And second step, we multiply the first row with 1 over 13. And the third step is we multiply negative 9 to first row and add it to second row in order to make 9 become 0. Okay. The fourth step, negative 7 in the first row, add it to row 3 in order to get 7 to become 0. Okay. Next step, 13 over 19, we multiply it with row 2 and we will get 19 over 3 to become 1. And next, furthermore, 4 over 13 in the second row and add it to row 3 to make negative 4 over 13 to become 0. Next, the next step, third row will be multiplied with negative 19 over 62 in order to get to make the negative 62 over 19 in the row 3 to become 1. Next, negative 8 over 13 in the second row add to first row. And the next, moreover, the negative 10 over 19 times with row 3 plus row 1 in order to get 10 over 19 in first row to become 0. Second last step, 2 over 19 multiply with row 3 plus row 2 in order to get negative 2 over 19 to become 0. And so here is the inverse matrix that we get. The last one. Okay. The last step is after we get the inverse A, we need to substitute inverse A into the matrix form, which is x equal to A inverse times B to get the price for each of the fruit. Okay, as we can see here, the equation of the inverse A will be multiplied with B. B equation, which is 101, 101, 74, and 47. So after we multiply it, we will get x equal to 5, y equal to 3, z equal to 2. And in a nutshell, we will get stuffed fruit is the price of stuffed fruit is 5 ringgit Malaysia, cherry is 3 ringgit Malaysia, and blueberry is 2 ringgit Malaysia.
So next, we can write the pseudocode for the question 3. So in the pseudocode, we can write the first start, read AB, A equal to 30, 8, 6, comma, 9, 7, 4, comma, 7, 4, and 0. For B, we can write 101, 74, and 47. And then we can calculate the inverse of matrix A. So we can write A underscore inverse equal to inverse A, and then calculate the prices of each type of fruit. X equal to A underscore inverse times with B. Then we print the prices of each type of fruit. We can print price of star fruit, price of cherry, and price of blueberry. So for the last step to write pseudocode, we can write the end.
Next, I'll explain about the about the C programming. Um, First, we need to initialize the matrix A and the vector B as stated in the slide. Next, we need to calculate the inverse of matrix A using double. Then, we need to calculate the solution for vector X. And then we need to print the results, which um, we need to print the price of one star fruit, cherry, and blueberry. The output can be seen in the next slides, which is star fruit. We get for each of it cost for the star fruit for is RM 5 ringgit, and then for cherry RM 3 ringgit, blueberry RM 2 ringgit. Let's proceed to the next question. For our last question, Aisha will present the question and its solution.
Okay, so this question is about linear programming. So I will read the question first. The question is, a health food business would like to create a high potassium blend of dried fruit in the form of a box of 10 fruit bars. It decides to use dried apricot, which have 407 milligram of potassium per serving, and dried dates, which have 271 milligram of potassium per serving. The company can purchase its fruit through it bulk for a reasonable price. Dried apricot costs 9.99 ringgit, about 3 serving, and dried date costs 7.99 ringgit, about 4 serving. The company would like the box of bars to have at least the recommended daily potassium intake of about 4,700 milligram and contain at least one serving of each fruit. In order to minimize costs, how many serving of each dried fruit should go into the box of bar? So we will solve this question using graph method. So first, for step 1, we will define the variables. Let x equal to number of serving of dried apricots and y equal to number of serving of dried dates. For step 2, we next work on the objective function. For apricots, there are 3 serving per pound. So the cost per serving is 9.99 ringgit divide by 3. So the answer is 3.33 ringgit. The cost for X serving would be that. For dates, there are 4 serving per pound. That means the cost per serving is 7.99 ringgit. divide by 4 equal to 2 ringgit. The cost for Y serving would be just be 2Y. Total cost we can do a equation like 3.33x plus 2y. So for step 4, normally we would have constraints x greater and equal 0 and y greater and equal 0. See, negative servings can be used, but in this case we are further restricted. In word, there just be at least one serving of each fruit. So x greater and equal to 1 and y greater and equal to 1. Thus, we have objective function. So we have objective function is the total cost. So the objective is C equal to 3.33x plus 2y and subjected to 407x plus 271y greater and equal to 4,700. This is the constraint is based on potassium in apricots and dates per serving. So we move on to the graph. So we graphed the constraint and shaded the feasible region. The region is unbounded, but we will be able to find a minimum still. We can see there are two corner points. So next slide. So we substitute the the number of one, the number of x, which is 1, into the constraint equation. So we get 0.1 and 50.8, and another one is 10.9 and 1. So the point is both of that. Next slide. This slide is shown to testing the objective function at each of these corner points. So we can conclude that the company can minimize costs by using 1 serving of apricots and 15.8 serving of dates.
Before we ended our presentation, let me state that we had achieved in discussion and conclusion. For the discussion and conclusion of this project, we will not only have a deeper understanding of business, but we will also understand how the math we learn in school enables us to handle any problem, no matter how small, both in exam papers and in real world scenarios. We really hope that people will like and find this project interesting, and maybe even alter their minds about math and realize that it's not so horrible after all. For the conclusion, in conclusion, we can see that math is tangible and factual in nature. This exceptional quality enables us to use math to solve problems in business. We tend to impose mathematical principles on the basis of blind faith far too often, despite the fact that examples like these are all around us. That is all from us. Thank you.